Hi everyone, I'm Yasmin Evian. I'm a product manager working on developer experience for Android XR. And today we are releasing the developer preview for Android XR SDK, Android's expansion into extended reality. From glasses you wear all day to immersive headset experiences, Android is bringing new capabilities for building integrated and boundless experiences. With our Jetpack XR SDK and Android XR emulator within Android Studio, we provided a suite of familiar libraries and tools to help accelerate development and enhance productivity for Android apps. This suite includes Jetpack Compose for XR for declaratively building spatial UI layouts, Material Design for XR for opinionated component and layout guidance, and adaptive components, AR Core for Jetpack XR for advanced perception capabilities, and a new 3D scene graph library, Jetpack Scene Core for 3D content manipulation. Our Android XR SDK for Unity provides packages to build or port powerful immersive experiences. Android XR supports open standards such as WebXR and OpenXR. Whether you're an Android developer or an immersive app developer, we want to support you with existing technology that you're already building with today. Android XR is an extension of the Android ecosystem, expanding upon our wide range of form factors to bring experiences that you love into a new dimension. We've made it intuitive to bring your existing XR and Android apps into this new space. We're leveraging existing Android technologies that you're already building with today, including our work with AR Core on mobile. But let's first talk about what can XR unlock for your app. Extended reality allows you to transport your users into a new virtual reality. With wide field of view headsets, they are unbounded by physical constraints, allowing you to build immersive spatial experiences with rich graphics and spatial audio. This new interaction helps you break up your content into multiple spatial panels that users can move independently, and also allows you to immerse them in new environments. Extended reality also allows you to blend reality, augmenting the physical world with the digital. Pass-through experiences allow users to stay aware of their physical surroundings, using plane detection to anchor spatial panels or 3D models onto a wall, table, or floor, which is perfect for seeing and interacting with products in real life. Lastly, in Android XR, interactions feel natural. Use hand and eye tracking to focus on objects and selecting with a simple tap. Voice input enables interactions when other inputs aren't readily available. For multitasking productivity, keyboard, mouse, and controllers are easily connected for familiar desktop inputs. There are multiple ways that you can build an app on Android XR. Developers can use existing technologies that we know and love from Android, as well as open standards with OpenXR and WebXR. To learn how you can easily port your existing OpenXR experiences to Android XR, tune into the Build Immersive Experiences with OpenXR and Unity session. To bring the full power of Android app ecosystem into this new form factor, all existing Android-compatible apps will be available to install via the Play Store, bringing the vast catalog of Android apps to XR with zero dev lift. In addition, we are making it more straightforward to extend your existing new app with new spatial and 3D capabilities through our Jetpack XR SDK. Let me show you how this all works in XR. When you first put on a headset, you're welcomed by Homespace. Homespace enables side-by-side multitasking with other apps. By default, all Android apps open in a single panel in Homespace. If your app hasn't been optimized for large screens, it will display in portrait mode without resizing capabilities. An app that is optimized for large screens will also work better in XR. Users will have the benefit of resizing and moving app freely within Homespace. To learn more about how you can make your app compatible and optimized for large screens, please read our guidance on developer.android.com. Now let's dive in how you can easily extend your existing Android app with the new spatial and 3D capabilities via our new Jetpack XR SDK. In full space, apps have full access to the immersive capabilities of Android XR. When an app enters full space, other apps are hidden and the app comes into full focus around you. With this unbounded space, apps are encouraged to design for the adaptive infinite display. With Jetpack Compose for XR, you can easily extend your existing 2D UI, whether it's built with composer views, into Spatial UI for XR. With composables, such as the spatial elevation and spatial dialogues, you can take advantage of the Z-depth by spatially elevating what's most important. With Spatial UI, you can break out your app into spatial panels and orbiters. Spatial panels gives users more flexibility to arrange their UI, such as resizing, moving, and anchoring around the 3D space. With orbiters, you can place app navigation and contextual action items to their corresponding spatial panel, giving users quick access to important controls. Android developers already familiar with Compose layouts, such as building with rows and columns, will find laying out spatial UI feels intuitive. By creating a spatial row, you'll declaratively be able to lay out multiple spatial panels side by side without having to manually calculate their position. Building upon these Compose concepts makes it feeling like building for spatial UI very smooth and effortless. And we're going to make it even easier. If you're building with the latest alpha of material design components and adaptive layouts, with one line change, all supported M3 components and layouts will automatically adapt for XR. Via the Enable XR component overrides wrapper, components such as the navigation rail and navigation bar will automatically be pasted within an orbiter. If you're using the M3 adaptive library, panes and list detail and supporting pane scaffolds will automatically adapt to spatial panels when Spatial UI is available. Simply add Enable XR component overrides wrapper to opt into these XR changes in your app. And you want to tune into our design talk to learn more about our guidelines for designing for XR. So I know what you're thinking, when can I start building? And I'm happy to share that starting today, you can build with the Jetpack XR SDK and see your changes come to life in the Android XR emulator within Android Studio. So get started, at developer.android.com/XR. The emulator provides a real-time look at how your app will look in XR. Whether you're testing your existing app for compatibility or you're ready to start building a differentiated app experience, the emulator will let you see your spatialized app, interact with content in a 3D environment, and experience your app as users will in XR. Building with Android Studio provides the same tools and workflows Android developers are familiar with, following the same process for creating a virtual device and deploying your app. A simple click on Run will build your Android app and open it within the emulator, where you'll be able to test how your app resizes and moves in XR. And just like the emulator helps you get a feel for how a user may interact with your app, the XR emulator is a great way of testing how a user may navigate your app in this immersed world, walking around a 3D object, seeing it from all points of view. And with Layout Inspector, you'll be able to see your app's layout hierarchy and UI attributes. You can use features such as the Android debugger when developing for XR, which allows you to add set breakpoints in your XR experience, evaluate expressions in real time, and even analyze threads to understand complex interactions. Android Studio is a great way to build and visualize your app in Android XR. To help you get started, we provided a template to help you build your differentiated app experience with Jetpack Compose for XR. Now let's welcome Patrick to show us how to build for spatial capabilities.
Thanks, Yasmin. I'm Patrick Fuentes, a developer relations engineer, and I'm going to walk through how to implement some of these spatial capabilities in your app. Because your Android app can run in both Homespace and Fullspace, as well as on devices like phones and tablets, the capabilities of Android XR might not always be available when and where your app is running. When you're implementing features that require spatial capabilities, we provide straightforward APIs to check for the capabilities that are currently available. When your app is running in Homespace on Android XR, you may want to enter Fullspace to enable Spatial UI. For example, maybe your app shows a video player and you want to transport your users to a luxury movie theater. Or maybe you want your app's UI to show real 3D depth. You can enter Fullspace with a single line of code by calling request Fullspace mode. When your app is in full space and you'd like to transition to Homespace for multitasking with other apps, you can transition just as easily by calling request Homespace mode. We encourage you to provide your users with a great experience, whether they're in Homespace or full space. Doing so will ensure that your app provides a great experience when multitasking with other apps or when running on other devices like phones, tablets, foldables, and Chromebooks. Let's take a look at how to implement some of these elements of Spatial UI, starting with orbiters. Orbiters can help to declutter your app's UI and draw your users' attention to important controls they can interact with. To change an existing UI element in your app into an orbiter, simply wrap it in the new orbiter composable and specify where and how you'd like it to attach to your app's panel. Doing so will extract the element from your 2D layout and attach it to your spatial panel as you configured. When your app is running in Homespace, or in other situations where Spatial UI isn't available, like phones and tablets, the content will remain in your layout exactly as it would if you hadn't wrapped it in the orbiter composable. As Yasmin mentioned, we're also introducing spatial pop-up and spatial dialog. Similar to orbiters, these components appear like typical 2D UI when Spatial UI isn't available, and they show your app's Spatial UI when they can. These components manage this enhancement so you don't have to. Using them is as straightforward as making a one-line change to replace the corresponding 2D UI element. Throughout all of the new APIs we're introducing, we try to leverage familiar concepts and workflows and require as little effort as possible to truly differentiate your existing Android app on Android XR. Let's say you already added some of these new components to your app, and you're ready to divide your app's UI into multiple spatial panels, one for your video player and one for your live feed of comments. To implement spatial panels in your app, you can simply wrap each composable in the new Spatial Panel API. Unlike some of Jetpack XR's new APIs focused on progressive enhancement, spatial panels are an example of the new subspace composables. These new composables represent spatial content that is only intended to be used in XR. You can build your own subspace composables using the new @subspace_composable annotation for UI elements intended to be invoked in your app's subspace. To modify subspace composables, we're introducing a new set of subspace modifiers. You can apply subspace modifiers exactly as you would with 2D composables. These new modifiers build on familiar constructs such as height, offset, padding, and width to help you get a head start on developing with these new APIs while introducing powerful new capabilities. When you're ready to use the subspace composable in your app, you can simply wrap the spatial content in a new composable we're introducing today, subspace. Within this element, you'll be able to call on subspace composables, such as spatial panels, to function as 3D containers for your existing 2D UI. This new composable allows you to create a dedicated space for your spatial and 3D content within your existing app, just as you would with any other composable. You can invoke subspace directly in your 2D UI hierarchy, so it's possible to extend your existing app to XR with small atomic changes. This means you can maintain independent layouts for 2D and spatial UI without losing context between different files. It makes it easier to extend your existing app to XR without needing to do things like hoist state through your whole UI tree or otherwise re-architect your app. And with that, back to you, Yasmin.
So thank you for letting me share how we're extending the Android development tools and toolkits you love to XR. With our Jetpack XR SDK, you'll have a smooth path for modifying your existing Android app to XR. Using familiar tools and workflows within Android Studio, you'll be able to visualize your app in this new space. Jetpack Compose for XR provides an easy onboarding to declaratively build your spatial UI layouts with familiar concepts such as rows and columns, and easy-to-use spatial UI components such as orbiters and spatial panels. If you're already building with Material 3 components and adaptive layouts, with the one-line change, you can see these new spatial adaptations in XR. Our spatial capabilities is just the beginning. We are bringing the advanced perception capabilities of AR Core for Jetpack XR, as well as Scene Core, our new 3D scene graph library for custom 3D manipulation. With Jetpack XR, we are enabling developers to add immersive elements to their existing Android app and help them build for this new dimension and making their experiences come to life. Let's bring Stefan to learn more about the AR and 3D capabilities available for Android XR.
Thanks, Yaz. Hi, everyone. I'm Stefan Silva, and I'm excited to share a little bit about our new AR and 3D spatial libraries available on Android XR. Today, we are excited to introduce our new 3D XR framework, Jetpack Scene Core. Scene Core provides a foundation for building 3D experiences, and it's built on top of powerful cutting-edge technologies that you're familiar with, like Filament, OpenXR, and AR Core for Jetpack XR, giving you the tools to create immersive and interactive XR applications with native Kotlin code. Let's dive into the basics of our 3D rendering API. We've built it around a familiar entity component system, making it more straightforward to define the scene around you in terms of entities and their behaviors described as components. Scene Core introduces a wide range of entities, including panels and 3D models, allowing you to create immersive experiences only possible in this new form factor. But that's not all. We've also included a range of AR capabilities, including the ability to create anchors with Scene Core. By adding anchors, you can easily place virtual objects in the real world with a simple API and configure how you want the items to be anchored semantically. For example, you can easily anchor a panel on a wall, a table, or floor. You can also define anchors to be horizontal or vertical surfaces. This type of simple Kotlin-based API is our latest approach for Android developers to create AR experiences across our ecosystem, and our goal is to expand it further in the future across other devices. You can also add 3D models to your scenes and create custom environments to immerse your users. So let's dig in. Let's start by talking about 3D models, which are helpful for visualizing things in real life, like furniture in your apartment. We've made it straightforward to bring your 3D models into Android XR by supporting the open standard GLTF 2.0 format, so you can use your favorite 3D authoring tools and import your creations seamlessly. We also support multiple GLTF extensions, including several that enable physically based rendering. You can position your 3D models, animate them, and even add input interactions. We're working on bringing native interactivity features like moving, resizing, and rotating 3D models directly within your app as well. You can also use Scene Viewer, our intent-based viewer, to open 3D models in a system app with built-in interactivity. Let's have Patrick show us both approaches to add 3D models to an app.
Thanks, Devon. Let's say you have a GLTF ready to use on your server, and you want to show it to your user. A simple way you can enable users to view the 3D object in Android XR is by using Scene Viewer. You can do so by creating an explicit intent, the same way you've done since the first versions of Android. This will allow the user to view the object and freely move and resize it in their surroundings. When you want more control over things like the position of the 3D model, the relative size, or fine-grained animations, you can load a GLTF resource directly in your app. Once the 3D model is loaded, you can use the volume composable to wrap a GLTF model entity and apply subspace modifiers to control how it's presented. Using volume allows you to declaratively place 3D models relative to your spatial UI. Speaking of animations, we support all the animation functionality in the GLTF specification, which includes skeletal animations, morph target animations, and node animations, as well as the KHR animation pointer extension. This already enables a rich set of functionality with 3D models, and we're just getting started.
Thanks, Patrick. Now, let's say you want to immerse a user within your app so they can have an environment that matches your experience, whether it be watching a movie, sports, or completing a meditation session. To help you do this, let's step into the world of environments. With Scene Core, you can transport your users to immersive virtual spaces. We support various open formats, including EXR and GLTF, making it straightforward to find the perfect environment for your app. Let's have Patrick show us how to add an environment to our app.
To change your user's environment, there are a couple of fundamental concepts to understand: the environment's skybox and its geometry. You can think of a skybox as a distant image that surrounds your users, creating the illusion of a distant background, such as sky, mountains, or a cityscape. The skybox is a high dynamic range image, which provides image-based lighting. This means the way that your user's surroundings are lit can be determined by the lighting information in your skybox. Geometry, on the other hand, adds shape and depth to your user's environment, creating real parallax effects for a more realistic sense of immersion. The geometry typically conveys the ground the user is standing on and the objects near the user in their environment. When you set the geometry for your user's environment, it's automatically positioned on the ground and it's gravity aligned. To implement environments in your app, you'll start with assets that achieve high quality resolution while maintaining a reasonable file size. To help you accomplish this, we provide guidance and optimization tools to support you in authoring assets. So be sure to check those out to get started. Once you have the right assets, you can load the skybox or geometry resources by calling on the methods on the XR session. Once the resources have been loaded, you can configure your environment preferences and request the system updates them. Note that the methods for loading these resources are asynchronous, so you'll want to do all of this off the main thread. Now, back to you, Stefan, to share more about what's new for AR Core.
Sweet. All right. And of course, we're pleased to announce our expansion to our well-loved AR Perception SDK, AR Core for Jetpack XR. AR Core for Jetpack XR is our Kotlin-based solution that allows Android developers to get access to powerful perception capabilities powered by OpenXR. This is our modern approach for our well-known AR Core Java API. To start us off, we have motion tracking to track the device's movement in the real world, plane identification to detect and label surfaces, anchors and persistent anchors to place virtual objects, and hit testing to interact with the scene. Additionally, we look forward to bringing hand tracking soon for our AR Core developers to create custom hand gestures for their apps. Both of these libraries will allow you to build immersive experiences with capabilities such as environments, custom spatial UI, 3D models, and advanced perception with Kotlin APIs. Feel free to check out additional capabilities such as spatial audio and stereo video features available in our Scene Core libraries. We will continue to expand our Jetpack XR libraries as we continue to build experiences with you, such as 180 and 360 videos. And this is just the beginning. We have many more features planned for the Jetpack XR SDK, including the use of our avatar capabilities. Apps will be able to access the user's avatar through the standard Android selfie camera APIs, animated in real time using the device's camera. The camera feed will contain the user's chosen avatar, including the Google photorealistic avatar or a third-party stylized avatar. We are also planning to make avatar APIs available for developers through Jetpack XR to bring their own avatars to Android XR devices in the future. Now, over to Patrick to share more on how you can publish your experiences for your users.
Once your app is ready to share with users, you can use the Google Play Developer Console to distribute it to your users' Android XR devices. If your app adapts well across other devices like phones and tablets, you can share a single binary across form factors. You don't have to manage multiple code bases or manage multiple builds throughout your app's launch and update processes. All compatible apps on Google Play will be available to Android XR users by default, so there's no extra effort required for you to publish. This approach can work well for many apps because the work you do to create standout experiences on other large screen devices can help your app shine on Android XR. For apps that are only suitable for Android XR devices, Google Play is launching a new dedicated release track for Android XR. This enables you to deliver specific builds just to Android XR devices without needing to do things like publish your app under separate package names, which can hinder adoption and confuse your users. Now back to you, Stefan.
Awesome. We've covered a lot of concepts. To put it all into context, let's look at Google TV to see what it takes to extend an app for XR. With Jetpack Compose for XR, Google TV was able to use their existing large screen optimized application to spatialize its UI. You can see how they've taken existing UI components and reimagined them on the spatial canvas. Beyond discovery, spatial panels add incredible value to the watch experience as well. Google TV also placed video playback within a dedicated panel, enabling users to easily move, resize, and anchor playback with an orbiter to give seamless access to playback controls. Scene Core gives developers the ability to change the virtual environment. Google TV has leveraged this capability to create a cinema experience all within their XR app, letting users transform any place into their personal theater. And the benefits of building directly on your large screen application is that it's simple to offer the same functionality alongside other applications in Homespace. Now over to Patrick to share more about developer resources available to you today.
With all the opportunities for you to lean into Android XR, we want to ensure you have the right support on your journey. As you're getting started, be sure to check out our design documentation, as well as our developer documentation. If you already have an Android app and you're ready to differentiate it for Android XR, be sure to check out our guide on adding XR features to an existing app. When you're ready to jump in and work with code, you'll find we already have resources ready for the developer preview. Our Hello Android XR sample app provides a straightforward example of the basic functionality afforded to Android apps in Android XR. In the sample, you'll see an implementation of spatial panels, orbiters, environments, and more. Once you're familiar with how to build, to ensure your app delivers a great user experience, we've also provided new app quality guidelines for Android XR. Like our app quality guidelines for other form factors, these provide a structured checklist for evaluating which details to focus on to ensure your app will delight users and stand out on Android XR. Your testing will likely go well beyond what's in the quality guidelines, but the quality guidelines are a great place to get started when you're wondering what high-quality experiences look like on Android XR. And with that, back to you, Stefan.
We've covered a lot today, but hopefully you're as excited as we are about the future of Android XR. The best part, you can start building with Android XR SDK today. Everything you need is available now. The libraries, the emulator, and all the familiar tools and frameworks you already know and love as an Android developer. Go to developer.android.com/XR to get started. Want to have even more hands-on experience with our unreleased hardware in partnership with Samsung? Apply to our Android XR developer bootcamps and get hands-on with the latest hardware and technology in 2025. For years, you've been building amazing apps in the 2D world of Android across mobile, large screens, autos, and more. Now, unlock the full potential of your creativity with Android XR. Step into the third dimension, explore spatial design, and redefine what's possible. This is an invitation to join us in this journey. This is just the beginning, and we can't wait to see what you'll build next. Let's build the future of XR together.